Hello, I am That Rob Human, and this is part 2 of my Tabletop Playground mod development series, in which we talk about objects versus templates. Before we dive into what the difference between an object and a template is, in my last tutorial series episode, I mentioned that you can use Git or GitHub, a Git repository, to collaborate with other members of your team. To that end, I've got this TTPG tutorial series repo up on my GitHub, and I'm going to come here and copy this code. Just copy that link real quick. And you'll see that in my Tabletop Playground directory, there is no test or tutorial series package here. Just the easy package that we made from the last series. Last episode, rather. And in my workspace, again, I have none here. So, gave the game away a little bit there. Anyways, so what I've done here is I'm kind of impersonating someone who you might be collaborating with, or maybe you're coming back to an old project that you have up on your GitHub that you're now coming back to or something. But essentially, this is just a quick guide on how to get someone functional in terms of working on your project with you, how to collaborate with someone. So because we created our workspace using the Create TTPG package and put it up on GitHub, it's actually really easy to get someone up to speed on this. Again, they will need VS Code, Node.js, and Yarn to make this work. So if you are collaborating with someone, send them to the previous episode first, so they have a chance to watch this. And if I remember, I'll put a card in the thing, because that's a thing. But yeah, so I have this workspace here. I'm going to shift right click to open a PowerShell window here. I'm just going to do a git clone. Right click there. Now I have Git installed for Windows. You might need to install Git as a client to be able to do this. Just search how to install Git on your OS of choice, and it should be pretty easy to do. If your repo is set to private, there might be more steps and a little bit of a hoop jumping exercise to get this to work using logins and whatnot. It's a little out of the scope of what I'm here for right now, but there are plenty of tutorials on how to start a Git repo and share a Git repo under private permissions out there. I trust your ability to find it. But I'm just going to git clone this. You'll see it created my TTPG tutorial series repo right in this directory. But it's not over here yet, and that's okay. So I'm going to cd into that directory. I'm just going to run code in that directory, and that opens up VS Code. Now, this might seem slightly familiar, but slightly less populated than before. And that's because when I uploaded this repo the first time around, it didn't actually have any assets in it, and Git doesn't track empty directories. That's not a problem. I'm going to hit Control-tilde to open up a terminal, and I'm going to do yarn install. And that's going to basically go, okay, well, these are the dependencies that I have in my package, and this was all sorted out by Create TTPG package already. It just kind of downloads them and shoves them into the node modules directory, which intentionally doesn't get shared in the Git repo. So they'll need to run yarn install first, and then they can do yarn dev. Oh, I lied. You can't do yarn dev yet. That's because right now you don't necessarily know where their Tabletop Playground directory is. You might know where yours is, but maybe they're on a different operating system, so might be in a different place. So it says workspace not set up, run yarn setup. So we'll do that. Yarn setup. Says okay. There's no local config file. I'll show you what that is in a second. But it says, okay, give me the path to the TTPG package or persistent download dir directory. In my case, it is this. which is exactly what its best guess has made. So I will say, yes, that's good. And there it is. And this is that local config, by the way. It basically says, where's the TTPG path again? It stores that, and it stores that outside of the Git repo. You'll notice that it's grayed out here. That means it won't be shared in your Git repository. And that's intentional, because someone's directory might be different from yours. So it asks them when they go to set up the workspace, what's their directory? In any event, now that we have that, we can do yarn dev, and everything's good. We have our assets directory, just as before. We have our dev directory, which is grayed out because it's not shared. That's kind of a temporary directory. And if we go over to Tabletop Playgrounds directory, there it is. Now at this point, they can start contributing to your mod. They can start writing scripts, or they can start adding assets. In fact, in preparation of doing so, I'm going to actually open up this assets directory. And I'm going to throw a model in here. It's just a debug model, and we'll get to why I did that in just a second. You'll notice that there's now a green file in here. That means it's been added to the Git repo. Hasn't been committed yet, but it's going to be added when you go to commit. In fact, I'm going to do something. There we go. Don't worry about what I just did. That's basically me setting up to branch for the next episode. So I'll do a git commit real quick. There we go. Now I've committed it. It's no longer green. We'll sync that up to the repository at the end of the episode. It'll be fine. So now where were we? Objects versus templates. So this is kind of our first big paradigm difference if you're coming at this from Tabletop Simulator. You see, Tabletop Simulator uses objects and just objects. In fact, if you ever get curious, go ahead and open up a save file from Tabletop Simulator, and you'll see that any object that is in the world gets fully enumerated in that JSON file. Everything that could define that object is defined in that save file, and that makes that save file huge. It also means that there is no distinction between setting up a game and running a game. Now, for some, that might be a positive thing. For me, though, I like the separation of concerns. I like the fact that the editor is the editor and the play space is the play space. That separation of concerns has actually been really helpful for me. I know it's a bit different from Tabletop Simulator, but I've come around to it. Okay, so objects and templates. What is a template? What is an object? The best way I can describe this, and I'm going to fall back a little bit on my programming experience here and try and bring you around to it if you're not familiar with it, is a template is kind of akin to a class or a prototype in object-oriented programming, which is to say, it is the basis on which an object is instantiated or created off of, spawned off of. A template will define the most generic and abstract behaviors, and all objects inherit those behaviors from the template. So if I create a template that is, you know, it's, I don't know, green, and it's a cube, and it has this model and this texture, any object will inherit that property, those properties, and some of which can be changed in-game. Some of them can be changed in the setup state, which we'll get to in a minute, and some of them can't be changed at all. And yeah, one of the big things I hear about people coming over from Tabletop Simulator to Tabletop Playground is, well, I should be able to change anything on a template as an object. And I can get that, but at the same time, if your expectation is that an object will behave in a consistent way, and multiple objects may behave similarly, then a template really is the more beneficial or more efficient paradigm to use. A classic example of this is if I have a chest or a crate or a barrel, something that just stores things, a bag, and the behavior of that bag is consistent between all the instances of that bag, I'll show you what that means in a sec, then why not have that bag as a template? So the example here is, well, if I have a bag of tokens, and the only difference between this template and the 7 different objects, one for each of these 7 different players, for example, is the color, then it really behooves you to have a template that you can change that one template's behavior, and it will affect all the instances of that object's behavior without having to go in and change each object. The other benefit to this is that now it makes save states more efficient. We'll get into that in a little bit here. But yeah, so effectively a template is the basis of objects, whereas objects are what you actually spawn in game. When you're actually running the game or setting up the game state, the initial state, objects are what you spawn in based off of templates. So why bother? I started to get into this a little bit, but it's the separation of concerns. Templates are edited in the editor, objects are edited in the game, and those two have very minimal crossover. There's some things that get duplicated or can be modified in the game, but generally the behavior of the object is dictated by the template. So it makes things a little bit easier in terms of the separation of concerns. The later game state and network load, by that what I mean is if you have your, say, 7 bags and they all reference the same template, well, that template gets shipped with the mod file. You upload it to mod.io, and a mod is a collection of templates and assets. But the game state is just, this is the game as it's running. The save file of the game state will reference the template and say, okay, this is the template you're using, just reference it by its ID, and these are the only changes from the template that have happened. So it really makes your game state really slim, and that has the benefit of making the network way more efficient, because you're not constantly changing and resyncing the entire definition. You're just going, oh, just the color has changed, or just the metallicity of the thing has changed, or just the name. It also means that, and this is the 7 bags example, shared templates between objects means that the behavior of those objects are consistent and predictable. You know, you don't have usually stray behaviors despite using the same template. So the bag is the quintessential version of that. If you have a bag that is say last in first out behavior and it's got this model and this texture, any object that you use can use that same behavior but change the color to coincide with each player that it belongs to. Now the con of this is, well, if none of your objects can be abstracted, you know, all your objects have different behaviors, then you might end up with one template per object anyways. I kind of don't consider this a con per se. I mean, it's a little bit more setup to do because you're creating a lot more templates, but at the same time, like, you've got one template per object, you're no worse off than if it were a purely object paradigm. The moment you have 2 objects referencing the same template, you are just that slightly more efficient in terms of inheritance and whatnot. And the other con is, well, I've had to make this tutorial. It's slightly counterintuitive. There's a learning curve to it. It's a different paradigm to what you might be used to with Tabletop Simulator, for example. Again, that's not necessarily a con per se, just a difference. it takes a little bit of getting used to. It's got a slightly different mental model to it, but I really think that once you get your head around it, you'll appreciate why it does that. And honestly, objects are a bit more flexible than what I'm kind of alluding to, and we'll get into that in just a minute when I load up this object, or this template. So to that end, before we dive into the distinct objects, I'm going to come into my editor. Now, the library isn't there because Tabletop Playground refreshes the list when you exit the editor list, not when you enter it. So there it is. I'm going to edit this selected package. And, well, we have objects, and really this is templates. These are your templates. So I'm going to create a new object, create a new template, really. And I'm okay with it just being generic. We'll dive into the anatomy of some of these in a later episode. In fact, I probably will end up doing an episode per template type eventually. But for now, we're just going to go with a generic one. We're going to select a model file, and this is why I threw that debug in there, just so that it was already here and I didn't have to go hunting for it later. So I'm going to hit OK, and then create. This is our debug thing. We're going to say generic template as the name of the template. Now, this is the template name, not the object name, even though the name of the tooltip says name of the object. It's not quite entirely true. Think of this as kind of an organizational tool to be like, this is what this template is. Objects will have their own name. Okay? I'm not going to dive too much into the anatomy of this. Again, future episode, we'll get to that in a minute, but I am going to change a couple things here just so that we have some noteworthy behavior that just looks a little bit cooler than that. Okay. So we've got our, we'll actually call this metal cuboid template. You don't actually have to call it template, I'm just doing that for explicit sake. I'm going to hit save down at the bottom, and this is our template. We could assign it a script, in fact I think I will. We can do all sorts of things, which again I will cover at a later time, but this is our template. So I'm going to go back, there's our template, and I'm going to come down here and go to preview package or create start states. Start states. It's terrible when you have a Lisp. So, what this mode does is it's kind of like a faux game state. It's almost like running a game, but this is the mechanism that you would do to build your initial game state for when someone starts the game afresh. So I'm going to start with an empty table, and I'm just going to use the glass table because I think it's classy. And I'm going to go with the station environment because I think its reflections are the prettiest. This is what I prefer. This is usually my setup in terms of my initial game state. So I'm going to right click, Object Library, and we're going to choose our metal cuboid template. You might need to check this checkbox to actually see the names. So again, this is the template that we built just a little while ago. I have now created an object based off of that template. In fact, I can create more than one. And right now, they are not distinct. And by the way, right-click Object Library, I can just keep spawning them, and I right-click to go back to the list, and then I can left-click outside of that to close that up. So I've got, what? A couple objects, all based off of the same template. These are objects. So I mentioned before that they inherit their behavior. Cool. In fact, if I go up here, there's a whole bunch of hello worlds, and that's because of the script that I'm running. They're all using the same script. But with objects, you can tweak some of their parameters. So I can right-click on here. I'm going to go to Appearance. I'm going to make that one red. So again, it uses the same template, but I can set up slight variations, some variations, we'll get to that in a second, of that template in-game. So again, if the idea here is that I'm creating the starting conditions of a game when someone loads up their game, I might want a cuboid for each player. In this case, let's do 3 players, red, green, and blue. Here we go. So I've got the green player's cuboid, the blue player's cuboid, and the red player's cuboid. Even though they're using the same template. And again, that fosters some consistency and predictability among their behaviors. Same template, different objects. The other things you can do is change some properties here. So for example, let's say I say red player's cuboid. You can change a couple other things like physics or even the script, though I wouldn't recommend doing that here. I think if it has a script, you should just make it the script. Again, we'll dive into the scripting in a later episode. Come into here, and let's say this is blue player's cuboid. And we'll change this properties to be green player's cuboid. Well, there's green player's cuboid, blue, and red. So again, this kind of fosters consistency and predictability and lets you kind of abstract a lot of the behavior into a reusable component. That's really the kind of the drive of this, is that it's component based. You're instantiating different types of components or different templates of components. Again, worst case scenario, you need to have a different behavior for each component. Well, then you just have a bunch of templates that you only spawn one object of. Worst case scenario is one template per object. Best case scenario is one template, huge swaths of objects. In the next episode, I think, unless I get a genius idea of what should be next in between those, we'll dive into a couple of the different kinds of templates that you can create and what their behaviors are and how they function. So with that, I will actually, let's actually exit out of here, and we will come to here, added cuboid template, commit that, and it's Control Enter to enter that, and we'll publish this branch. And if I come back to my Git repo, here we go, 3 branches, part 1 and part 2. And this is not going to be an exhaustive tutorial on how to use Git. I might do that if people end up needing it, but I'm just going to check out main, check out Git, check out main. Cool, and I'm going to merge into current branch. Cool. Done. And that means the main branch is now up to date. So after every episode, I will sync the main branch to be the latest episode, but you can always go back to the history by going to the branches. And these should be fully public, so you can always, one of the things you can do is check out part 1. Check out part 1. And then this is the state as though it were part 1. Or you can get check out part 2. And we're back to the state. It's kind of how Git works in version control. Again, it's not going to deep dive into it, but if people want help in using Git as a collaborative tool, more than willing to do it, just shoot a comment. Anyways, that should cover that. Next episode, we'll get into object types and template types. Until then, good luck.